Here's another video example of energy inefficiency, and this is a door that leads to the outside of the house, and there's a gap between the door and the floor, and this is what would allow a draft to flow. So in winter, the heat of the house would escape through that gap to the outside, and in summer, obviously the opposite would occur. The heat from the outside would come in, through the gap as a draft to the inside of the house. So in both situations would require more energy to operate, the air conditioner or the heater for longer. So you're wasting power. Okay, so here's the thermal camera again. So we're going to aim that at the door. Okay, just at the gap, and you can see very clearly where it's blue. Obviously, it's colder than its surrounding environment. Okay, so the temperature of the floor is around the 17 degrees, so I'm just aiming it at the floor there, about 17 degrees. The door itself is a little bit cooler, okay, so depending on how well insulated the door is, the gap, okay, so I'm just going to change the mode on the thermal camera to reading cold temperatures instead of the warmer temperatures. And we can see there that the gap's a little bit cooler there. It's in the 13 degrees, so at 13.7, 13.8. So it really depends also on the difference between the inside temperature and the outside temperature as well. So these drafts, what could we do about it? Okay, so that's a very simple thing to fix actually, but enough of these around the house could mean that you could be operating the air conditioner, maybe for a good half an hour, 1 hour, maybe more per day, and also on a higher temperature or a lower temperature, which means that you're running the air conditioner or the heater harder, right? Using more power to fight against the energy inefficiency of this draft. So there we go, back to the gap again. So again, easy problem to fix, but another example of energy inefficiency, but another opportunity to be able to fix that problem and then start saving power.